Hello and welcome to this course on data warehouse and data warehouse lifecycle. I'm Kokshen Yang and I'm your instructor for this course. In this video, we will go through the data warehouse in a modern data stack. The role of the data warehouse in a modern data stack. So we'll start with an example. Analyzing ice cream sales may require disparate sources of data. So we have data from different sources. We could have point of sale system. And this is the place where we sell the ice cream. So we get the date and time of purchase. We get price per unit, sale amount, payment method, store location, etc. We could have inventory management system. And here we have stock levels of ice cream. We have reorder points and quantities, inventory turnover rates, spoilage or wastage data. We have supply chain and logistics. And here we have supplier info and delivery schedules. We have transport and distribution data, lead times and shipping costs. We have weather API. We need to know the temperature, the humidity weather conditions, historical weather data, and have weather forecasts, etc. Because this affects our ice cream sales. We have marketing and ads platforms. For example, we use Facebook, we use Instagram, maybe LinkedIn, etc. And there's a lot of data there. Maybe promotional ads also. We have promotional offers, etc. Maybe we use newspaper, we use marketing campaigns, etc. So there's a lot of data there also. We have social media platforms. I already talked about it. And we have maybe demographic data. We want to see, is there certain age groups or certain demographics that buy more ice cream and certain type of ice cream. For example, maybe where there's a lot of families, they buy a lot of family packs and mixed ice cream, for example. So this is also very good to know when you want to sell ice cream. So we see that we have data from a lot of different sources. So it can easily become a mess unless you know a lot about data modeling and data warehouse. So this is what some of the data could look like in the disparate sources. We could have supply chain, for example. We have different product name, category, stock level, reorder point, etc. We have point of sale. We see we have sale ID, date, time, product ID, quantity, a lot of other things. Social media could look like this. We have some from Twitter, Instagram, Facebook. Weather data could look like this. So we have, and demographics could look like this. And these are just a few examples. And as you see, it becomes a little bit messy and unmanageable already. You can pause here and look more into the data if you want. But I'll move forward. And the formats of the data, it can vary also. So sometimes you have structured and semi-structured data, such as CSV, Excel, Parquet data, or JSON. So these are structured and semi-structured. And there could be different databases. For example, the data could live in PostgreSQL. It could live in MySQL, SQL Server, MongoDB, which is NoSQL. It could be unstructured data, for example, text data, Word file, PDF. There could be other unstructured data, for example, MP3, video, images. And the data can be scattered in different locations. We could have on-premise servers. So these are physical servers that you have on your company. There could be different people's computers. So for example, I have one Excel file. Another person could have another Excel file. Another colleague elsewhere could have another Excel file. And we could edit it in different ways. So we don't know which one is the source of truth. That is very dangerous, but it happens a lot. There could be in different file storage systems. We could have in iCloud, we could have in Dropbox, Drive, or OneDrive, I meant the first one. OneDrive, we have Google Drive also. Yeah, I forgot the symbols a little bit. We could have different cloud vendors. So we could have AWS, could have Azure, we could have Google Cloud Platform. We could also have others. And the data could live in different APIs. So in order to access the data, we have a REST API, for example. For example, the weather data, it's probably an API that we will get the data from. Also, data gets updated with different frequencies. And this is important that the data visualizations, the reports, the predictions to stakeholders, they must reflect reality to properly support decision making. We don't want to base our decisions on false data or on outdated data, because that could lead to misleading decisions or decisions that are not optimal based on the given data we have. Also, this could lead to mistrust, so they don't trust the data anymore. So if the stakeholders don't trust the data, there's no need for us to work with it, because gaining the trust is very, very difficult. So, okay, now I've talked a lot about the messiness of the data, and it's scattered everywhere. So we need to have something to keep it in place and have control over it and model it. So we meet the data warehouse. So we have different data sources from disparate locations. It goes into our data warehouse. And then we can use the data from the data warehouse and serve dashboard, serve analytics reports. We can serve ML use cases, machine learning and AI. So in this case, we have data from upstreams. Here is the upstream, different data sources. It's going down to a data warehouse, which is downstream to the data sources. And here a lot of transformation is happening. And then we serve downstream dashboard and ML models. That's cool. So the data warehouse, what is that? It's basically a central repository. We have data from disparate sources. We have consistent and comprehensive data analysis. That sounds really good. We have current and historical data in one place. Note that this is different from OLTP systems, which are, for example, MySQL, PostgreSQL, and SQL Server. These are OLTP, transactional operational databases. Here, you don't have historical data. Your data reflects what it is right now. But in the data warehouse, we keep the historical data so that we can analyze the data over time. They serve different use cases. And the data warehouse is an OLAP, so that we contrast it against OLTP. So OLAP is online analytical processing. We have separation from operations. So the data warehouse, we have the data separate from the operational databases. So we do our analysis in the data warehouse, not in the OLTP operational systems. So it doesn't impact the performance of the operational system. We separate compute and storage. And this is quite useful when we want to scale. We want to scale it separately. So we want to scale the storage. We want to scale the compute separately. But we'll come into how we'll count the costs, etc. later on. It's very scalable. There's some scaling horizontally. There's also scaling vertically. And we'll come into what these terms mean later on also. And we have data warehouse to support business intelligence, analytics, reporting. And in data warehouse, OLAP is the most common, as I mentioned before about OLAP. So in this course, it's about the data warehouse lifecycle. So the data warehouse is one part of it, but we have a lot of things happening around it. So what happens? We have business requirements. Usually it's the data team should work together with the business, the stakeholders. And we do data modeling. We model how we want to build the data warehouse, how to store the data, how to serve it. And in here we'll come into something called dimensional modeling, and we will come into something called star schema, which is quite common for data warehouse modeling. So it's from Kimball methods. And we have ETL and ELT development, which we'll come into in the course. It's when we want to extract and load the data from different sources into the data warehouse. So this is the data ingestion part. And then we will transform the data so that it can be served to various stakeholders. And very important is that we test our data. We don't want to serve faulty or misleading data. Maybe the source system has some errors for some reason, or someone has typed in the wrong value. And then if this comes through to a dashboard, and it could see like, oh, our sales have dropped 40% or something, then the business will start to scream at everyone and ask, what has happened? What has happened? And if it was due to a bug or a mistake in the data, then they might not trust the whole data pipeline anymore, and they won't trust your data engineering team. So testing is very, very important, and we will go through it in detail later. And then we'll deploy it. We'll deploy, for example, we'll deploy a dashboard. We can deploy the data warehouse. And of course, we need some maintenance. We need to continue to work on the data warehouse and continue to make it up to date. And we need to orchestrate these things also. So for example, we have one data, we have one ingestion per day, for example, so that we get the fresh data each day, or another interval that we decide. But then we need to maintain the data warehouse. And then usually it comes new business requirements, of course. And in order to meet those requirements, it's very good that we have had done data modeling and dimensional modeling. And we'll come into something called grain in dimensional modeling. And then you'll understand that the more atomic the grain is, the better to have higher chance to meet various different business requirements. It's easier to slice and dice the data if we have defined an atomic grain or close to atomic grain. Yes, so this was the introduction to data warehouse and data warehouse lifecycle course. And so welcome very much to this course, and I hope that you will enjoy it. Thank you.